Going on a little early here. Welcome aboard, folks. Let's do some experiments. Let's get this turning on here. There we go. Make that look nice and pretty. Okay. We're going to do some titrations tonight. Oh! I got to go get... Well, the live hadn't quite started yet. I forgot my soda pop. I'll be right back. Okay, sorry about that. It's time for the live to start anyway. Okay. Yeah, we're going to do some titrations tonight. Hello there, Welpsy. I don't know why you're the only person here. Let's get my soda pop out. Little Sprite Zero. We're going to try looking at that tonight. Let's add a little bit of water to our flask here. There we go, deionized water. That looks good. Got a nice little, hey, let's fill that a little more. I want that vortex to look a little better. I think that looks a little prettier. What do you think? Huh? Okay. Thank you there, Welpsy. I appreciate that. Glad to hear you're subscribed. That looks nice like that. I'm going to leave that just like that. Okay, let's go ahead and add some universal indicator to this flash, shall we? I'm going to turn that speed down just a bit. Just a bit. And what are we going to add here? Universal indicator. It's also known as rainbow indicator. Changes color depending upon pH. We get enough people in here, we're going to start doing the titrations. Looks like that's a little bit basic. Just a bit. We got a nice aqua color. This flask probably had a little bit of base in it to begin with. A little more. There we go. That's a nice aqua color. That aqua color tells me the pH of my mixture, which is how acidic or basic it is. I'll show you here. Here's our pH scale. Right there. So you can see it's like an aqua. It's basic, pH 8, okay? And I'll just add a little bit of acid or base to this. We'll check it out, see what happens here. Here we go. Let's add a drop of acid. 1 drop, here we go. In it goes. Beautiful. Let's add another drop. Oh, that's a nice color change going on there. Let's add some base. We'll drop a base. Ooh, that's beautiful. Absolutely beautiful. Let's check this one out too. We'll do another one over here. We'll do a slightly different one. Let me get this set here so it looks nice. Okay, get that going. Ah! My stir bar went a little crazy. Okay, this one we're going to set up a little different. So this one's just got water in it. Add another drop of acid over here while I'm setting up the other one. Add another drop of acid. There it goes. Beautiful color changes going on. Now we'll check this one out over here. I'm going to get a little water going in this one. Here we go. In it goes. We get up to about 100 people, I might do the titration of soda pop, I think, in a smaller flask. We'll compare Sprite and Sprite Zero. Okay, that looks pretty good. What's going on, Lawbit? Hello there, Hanada. Official. what's happening? What is happening in this flask and in this flask? I just got them on magnetic stir plates, so they're getting stirred. This one has universal indicator added to it. This one does not. Universal indicator tells you pH, or how acidic or basic something is. So you can see this material over here is acidic. It's called science, baby. So this is over here, we know that's acidic because as I look at my pH scale here in the middle, it looks red or orange, so my pH is like 3 or 4, so it's acidic. Over here on this side, I don't have any indicator added, so let's add some to this one. Got a little bit of indicator over here on this side. Let's see what the pH is in this flask over here on the right. Just for the heck of it, here we go. Here we go. 1 squirt, and that's yellow. So this is slightly acidic. I'm used to seeing that. I'm used to seeing water. That's actually purified water, distilled water. I'm used to seeing purified water at a pH of 6, slightly acidic. That's because there's a little bit of carbon dioxide dissolved in there. And when carbon dioxide dissolves in water, it is indeed acidic. So that's, you know, common to see. All right, here's my lid to this. You won't put your hand in it. Yeah, it wouldn't bug you. It's not that bad at all. Okay, so now what I'm going to do on this flask over here. What's this about? We're doing some science experiments. So here, check this out. So you just get an idea of what the universal indicator does, okay? You wouldn't want to drink it. One of the indicators in there, one of the dyes is a laxative. Now that might end the live pretty quickly. So we're going to see what the indicator does in this flask over here, and then I'm going to use it in an experiment over here. So in this flask over here, you can see the pH is 3, right, which is acidic. Watch what happens when I start adding some base to this flask. I'm going to add just 1 drop here, just 1 little drop. And wow, that pH changed from 3 to 10 pretty quickly. I mean, just really rapidly. No, not like that, Jay. It's, I mean, sure, all acids to a chemist mean just a particular thing. It just means that it donates protons. So let's add a little bit of hydrochloric acid. This is the same acid that's found in your stomach. I'm going to try to add just a tiny drop, and I'm going to do that just by adding just, you'll see it, I'm going to just touch it to the side right here. And that makes it so I don't add quite so much. Look at that, we got a little rainbow going on. I love it when that happens. So you can see the pH after I added the acid, it's dropped to pH 6. I don't have any bread downstairs in my basement there, Whelpsy. Let's add another drop of the acid, just a little tiny one. And then our pH goes all the way down to 3. Goes pretty quickly over here. Thank you there, number 1. So over here on this side, what we're going to do is instead of just doing this with water, I'm going to add over here a little bit of milk of magnesia. Milk of magnesia is a base. Okay? So, of course, if I add this, we're going to expect the color to change. Thank you there, Fossil. I love the rainbow too, man. It looks really cool. Wait till you see what's coming, though. Wait till you see what's coming. So I got pH 6 here. I'm going to add a little bit of milk of magnesia to this. Milk of magnesia is also known as magnesium hydroxide. It's a base. I'm going to add a full squirt of this in here. LOL bit, indeed. Here we go. There's my milk of magnesia. In it goes up here. Squirt that baby in, and look at that color change. It turns green as it neutralizes that little bit of acid that was in there. And as the milk of magnesia continues to dissolve, you might see that green change to aqua, so we're at pH 8. I'm going to continue to let that dissolve. And as it continues to dissolve, you know, you might notice the pH go to like 9, like a more blue color. And it may even get to a violet color if I let that go long enough. So there's huge differences here. This is acidic. This is basic. All right. How does it happen, Hanada? How it happens is there's a mixture of dyes in these flasks known as universal indicator, and universal indicator changes color depending upon pH. So these are the different colors you're going to see. So they're very different pHs in these flasks. This is pH 3, which is quite acidic. This is pH 10, which is quite basic. You'll also notice that you can see through this flask and you can't see through this one. And that's because the milk of magnesia, there's little solid particles of it in here that have not dissolved. So that's right, you can't see the tornado whelpsy over here because there's little tiny solid particles that are blocking the light from getting through. So in addition to some of that white solid that I added, in addition to some of it dissolving, some of it remains solid. Okay? Jason, what I put in the glasses is a little bit of universal indicator. It changes color depending upon pH, like you see here. All right. You don't want that, Malcolm. One of the indicator dyes in here is a laxative. Okay, now check this out. Check this out. I'm going to add a drop of hydrochloric acid to this. It's the same acid that's in your stomach. Akuma, the maximal pH can go very high. The maximum that this can display is 10. So, you know, you'll see it turn violet at 10 and above. Here we go, baby. We're going to add a drop right up here. You can see me adding it. A drop of hydrochloric acid. Let's do 2 drops. Turns red. And then, remember, there's still some solid magnesium hydroxide in here. That solid magnesium hydroxide reacts with the remaining acid and neutralizes it, changing the pH back to a basic pH. And then again, as you know, more of the magnesium hydroxide dissolves, it does so slowly, it'll eventually get back to a purple color again. It just takes a while. So you can tell, again, you can tell that there is some undissolved solid in here because you can't see my hand, all right? And over here, you can see through very easily. And notice a difference too, watch this. Over here on this side, I'll make this basic by adding a drop of base. Jason, it depends what you mean by super acidic. I'm going to add a drop of base over here. Oh, we got the rainbow flash. Let's add another drop. So yeah, now we got like a pH 10 over here. Roughly pH 9 or 10 over here, you know, the blue color. Yep. Oh man, they had a hydrochloric acid leak from a train car in LA. Depending upon the concentration of that, if that stuff gets into the air and you inhale it, that's not real good. Anyway, let's watch the difference now. They're both basically basic. This is pH 10, this is pH 9 or 10. Over here, I'm going to add a drop of acid. Andy, you can drink it, but you're going to end up on the toilet a little while later because the dyes are laxatives. Here we go. I'm going to add a drop of acid. Actually, let's do one over here on the left. Let's do another drop over here on the left. And you can see that pH changes to red, and it persists. The strongest acid, number 1 fossil that I'm aware of, is fluorantimonic acid. Okay, here we go. Now we're going to, that's remaining red. Watch what happens when I do it on this side, however. Okay, here we go. 2 drops of hydrochloric acid. 1, 2. Of course, we get the red, but in this case, it won't stay red. All that's here is water, but over here, there's also magnesium hydroxide. And that magnesium hydroxide, that's the solid stuff that's in here. That's going to neutralize the acid, just like it does in your stomach. That's why people drink this stuff, right? I mean, that's why people drink milk of magnesia. So it's going to neutralize the hydrochloric acid, and then some more of the magnesium hydroxide dissolves, and as it dissolves, the pH is going to go higher than neutral. Isn't that cool? Very, very cool. All right, let's add another drop here. We can do this again. Here we go. 2 drops of acid, hydrochloric acid, same acids in your stomach over here on the right. 1 drop, 2 drops. Turns a nice red color. We're going to let it ride a bit. As the solid magnesium hydroxide reacts, it shifts through all the colors. It's now been neutralized. So the acid's been neutralized, and now some of the solid magnesium hydroxide dissolves. And as it dissolves, it pulls the pH to pH 8. And if we keep going, it'll go like pH 9 and 10. You see it's like pH 8 now. Oh, I'm sorry to hear that, Abrar. Thank you there, Joyless. Thank you there, Zach. Thank you there, you're smart. Thanks, Welpsy. It's a magnesium hydroxide, Zach. It tastes like a really bad evening, Timo. Well, one of the dyes is a laxative. All right, here we go, Kevin. Kevin wants to make it red, so I'm going to add some acid. If we add acid, the pH will drop. All right, make it pH 3 or so. So let's add 2 drops here. So as the acid dissolves, the pH drops. However, there's magnesium hydroxide in here, and that magnesium hydroxide neutralizes the acid. That's why the pH went from 3 up to green. It's been neutralized. And now the pH continues to rise because there's some of this solid magnesium hydroxide that dissolves, and that's a base. So we're at pH 8 right now. If we leave that go, it's going to go even higher. Andy. Yeah, Zach, it'll continue to neutralize as long as there's some of the solid present. So you might tell it's getting a little less opaque. As the solid dissolves, it's going to get easier and easier to see through here. And once all the solid dissolves, if I add the acid, then we won't see that effect where it changes back to the blue color again. So long there, Welpsy. Hello there, N. Buxy. Hello there, Ariz the Cuber. Here we go. We are going to... Hey, hello there, Lebanon. What we're doing right now is we've got 2 flasks with some universal indicator in them. This one has just water and universal indicator. This one has milk of magnesia and universal indicator. Let's see what happens if I add some base, sodium hydroxide, to the flask that just contains water. Let me get this out of the way. These are the different colors you're going to see. They just tell you the pH or how acidic or basic something is. Here we go. Let's add a drop of base over here. And wow, that pH changed dramatically from pH 3 to pH 10 with 1 drop of base. So both these are very basic right now. This is like a pH 10 violet color. This one's pH 9 or maybe 10, somewhere in there, a blue color. I'm going to add a drop. Let's go 2 drops of acid over here to this one. This just has water in the indicator. So there's your 2 drops. Got a little rainbow effect there as it was going on. But as things settle down, you can tell that the 2 drops of acid have made this red, which is a pH 3. Just took 2 drops. No, this stuff isn't flammable. If we go over here, we're going to do the same thing to this one that has magnesium hydroxide present in it. And let's add 2 drops of acid to this one. Of course, the pH drops as we would expect. However, the magnesium hydroxide reacts with the acid that's been added, and that makes the pH rise as it neutralizes the acid. Right now, we're at green, which is neutral. And then we've neutralized the acid. As the magnesium hydroxide continues to dissolve, that green color will fade to like an aqua as the pH rises a little more as the base dissolves, and then it'll go to like pH 9 blue, pH 10 violet. Wyatt, we're learning some science and hopefully having a little bit of fun. Would this help remove rust? It potentially could, Zach. What you'd want to use there is citric acid. Andy. It looks like, I'm sorry, I don't know how to say that. I don't know how to say the word. Yeah, it might look delicious, but I'm not thinking that you're going to want to drink that stuff. Hello there, Zachary. So yeah, we get enough folks in here. I thought it might be fun to titrate or to figure out how much acid is in Sprite. And then we can compare that to how much acid's in Sprite Zero. We can actually do an experiment to test that. That's coming up later. We get enough folks hanging around in the live. We'll do that. We'll do that experiment. Okay, here we go. We're going to add 2 more drops of acid to this flask over here on the right. 2 drops. Boop. Boop. In they go. Of course, it turns acid as the acid's added, but then the magnesium hydroxide that's present in the flask will slowly neutralize it. Timo, indeed, it is changing into a salt. Let me show you the chemical equation that's going on. Oh, we're up to pH 6 as the magnesium hydroxide is being neutralized by the acid. So here's the chemical reaction that's going on. The magnesium hydroxide reacts with hydrochloric acid. It makes water, and there's the salt that is made, magnesium chloride. And we may have gotten to the point where I've used up all the magnesium hydroxide. You can see it's now transparent. And the acid that's been added has just been neutralized. Our pH is 7, and I don't see it fading back to a blue or violet color anymore. So we're pretty much stuck at pH 7. So let's add a little bit more magnesium hydroxide so we can continue to do the experiment. Kevin wants me to make it green on the left. What do you got, Wyatt? I want to see your question. What's going on? I didn't steal anybody's Sprite. What my effects on my body be if those potions were ingested? Jazz, the dye that I'm using called Universal Indicator, it contains phenolphthalein, and phenolphthalein used to be used in X-Lax. Here we go. I'm going to add this white stuff, which is magnesium hydroxide. Well, it's milk of magnesia, which contains magnesium hydroxide. Magnesium hydroxide is a white solid, and it's just suspended in some water here. So here we go. I'm going to go ahead and add the magnesium hydroxide. And it gets cloudy because the solid, a little bit of it dissolves, but not all of it dissolves. And you can see the pH has now gone to like a pH 8, maybe even pH 9. Yeah? Like a pH 9. What if you put something on it? It's cloudy like your soul. I'm so sorry, Timo. All right, now that I've got the base, let me show you the chemical reaction that's going to be happening. So this is the magnesium hydroxide. That's solid particles. A little bit dissolves, and that gives us hydroxide, which makes it basic. I'm going to add acid. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach, and it'll neutralize it, okay? These are neutral salts or water. Yeah, I could touch it if I wanted to, but I don't know if YouTube would let me, they might not like that. So I don't want my live to get blocked. Okay, here we go. Let's add 2 drops of hydrochloric acid over here on the right. It'll get neutralized by the magnesium hydroxide. And when it's neutral, it'll be green. And then, there it is. It's been neutralized, and now the solid will continue to dissolve. And as that solid dissolves, it'll make everything a little more basic again. Thank you there, Jazz. Zachary, you got it, man. You got it. You let me know the channel name there, Zachary. Thank you there, Tyler. Let's do it again. Let's see here. Here we go. Let's add 2 drops here. 2 more drops of acid. What's the name of this reaction? Yep, just drop it in the chat there, Zachary. Just tell me the name there, buddy. It did look a little like Mountain Dew. So here's the chemical reaction that's happening over here. The solid is magnesium hydroxide. It's a base. A little bit of this dissolves. Zach, I'm not a synthetic chemist, Zach. So the magnesium hydroxide, as it dissolves, it turns this basic, which is going to be like a pH 8, like the color you can see now, or a pH 9 or a pH 10. As I add the acid, this reaction will happen. The magnesium hydroxide will get neutralized, all right? And then if there's excess acid, the pH will go very low. But then the solid that's present will continue to react with the hydrochloric acid, and then we'll see the color reappear. So here we go. Are there any applications of this reaction? Absolutely, Vitable. This is how you can neutralize excess stomach acid in your stomach. So Zachary's, pop that up there a few more times there, Zach. 3D Nation 3. Zach's got a channel he wants folks to check out. There's 2 drops of acid in there for you. So right here. And then you can see, there it is. The color's shifting back. That's good, Zach. Thanks for letting us know. You're welcome there, Zach. Are alkaline and basic synonyms? Yes, pluripotent. Here in the United States, we use those 2 terms as synonymous. Thank you there, Cannibalistic. Let me tell you what's going on. I've got 2 different flasks here. One contains an antacid. The other one does not. Both flasks contain some universal indicator, which is also known as rainbow indicator. Rainbow indicator changes color depending upon pH, which is how acidic or basic something is. So here, if you watch, I'm going to go ahead and add a drop of base to this flask over here. In it goes. One little drop. And you see the color immediately change. Actually, there's a little flash of rainbow there. But you can see that our pH is now 9. So addition of base will cause the color to change. This is also pH 9. Let me add a little bit of acid over here on the left. One drop. And the pH changes quite rapidly, and it stays put. Over here, we're going to add 2 drops of acid. And look at that, the color shifts back. Yeah, we're live. We're definitely live right now. That's right, Tyler. Yep, this is a rainbow indicator. Very cool, eh? Very cool. The right one looks gritty. Indeed it does, Jazz. The right one's gritty because there's little tiny solid particles in here that are not dissolved. And those tiny solid particles are a base. And they will react. Watch it up here. I'm going to add some acid. They'll react with the added acid. So I'm going to add 2 drops. So it turns acidic at first, pH 3, but then the solid reacts with the acid and it neutralizes it. See, we're at like pH 7 already. And then as the solid dissolves, it'll make this basic. Camera angle was better before. I like that, eh? Yeah, let's go in a little tighter. See if that helps. I don't know. See if that's a little better. Let's add 2 more drops of acid over here on the 1, 2. On the right, we've got a little rainbow swirl there. Of course, the acid's going to get neutralized by the antacid that's in there. Tyler, it will keep doing this until the solid particles that are in here are consumed by the acid. Jazz, basic means alkaline. A base is the chemical opposite of an acid. They react with each other and neutralize each other. Hey, hello there, Centrum. Can I make 5 plus 10? Let's go for it. Let's go for it. So this one's easier to get to 10 over here. So I'm going to go ahead and add some base over here and get this to 10 real quick. There's your 10. pH 10. And then over here, Carter, we'll talk about why it's turning colors here in a second. I'm going to add a couple drops of acid. And when we see that orange, we got pH 5, like an orange yellow. We'll back it off. There it is, man. 5. There it is right there. It was just for a flash, but we had 5 and 10 just for a second. So they're changing colors because I have added universal indicator to both flasks. And universal indicator changes color depending upon pH. So antacids are extremely basic. Antacids are indeed basic, cannibalistic. They are indeed basic. Can I mix it? Asks Sebastian. Yeah, we can mix these. We can certainly mix these. Let me try to neutralize the base over here. You can see I've pretty much neutralized the base. Let's see if I get it all here. So you guys want to try to measure how much acid is in Sprite? We can do that by adding careful amounts of base to it. We can do that, and then we can do the same thing for Coke Zero if you want. Knighton, I won't be doing that anytime soon. Hydrochloric acid, excuse me, the universal indicator that's in here, one of the dyes is a laxative. Yeah, it's okay. People drink acids all the time. So citric acid is an acid, and that's an orange juice. Cool there, Slushy. Glad to hear it. Look like Joker colors right now, huh? Okay, let's do this. Let's try another experiment, shall we? Let's get the titrations ready. Titration, that just means you're going to carefully add one type of chemical to something to figure out how much of a chemical's in there. Okay, let me, I got to get another stir bar here. Okay, take this one off. And what we're going to do now is compare the amount of acid in regular Sprite and Sprite Zero. That's what we're going to do, all right? So the question is, which of these two cans of soda do you think has more acid in it? And we can use this experiment here to figure it out. What are we thinking? Team Sprite or Team Sprite Zero? I don't know. Let's find out. Come on now. Here we go. Yeah, I can drink the Sprite and Sprite Zero after. That's not a big deal. I don't have any Mountain Dew, Wyatt, but I could always test it. So, which do we want? Let's do the Sprite first, shall we? Sprite Zero, Sprite Zero, Sprite Zero, Sprite. Is sugar acid or base? Great question, Slushy. Sugar is neither acidic nor basic. Neither acidic nor basic. So let's try it here. Okay, we're going to start with the Sprite. So I'm going to open up the Sprite. All right. And then we're going to pour the Sprite into this flask. We got to make sure we use the same amount for each one. We're going to find out, folks. We're going to find out if there's a difference in acidity between the two. Okay, and to make sure that I'm getting the same amount, let's get another flask up here. Same size flask. All right. I'll put this Sprite over here so we know which is which. I got to keep track of that. So there's my Sprite on this side. And then on this side, we're going to do our Sprite Zero. So I got to make sure I get the same amount in there. Oh, there we go. There it is. Let's pour it in. So here's the Sprite Zero. Get the same amount. Sounds delicious, doesn't it? What do you think? Is that about the same amount? A little more of this. Just a bit. A little more. Just a drop. I think that's pretty good. What do you think? Yeah? Close enough? I'm thirsty too. Okay, I'm going to pull this one over here. We're going to have to test. Well, I guess we can test them both at the same time. I didn't think of that, but I think I can pull that off. So let me get this one spinning. Get that little guy spinning. Come on, baby. Get going. There he is. Spinning away. Yeah. And then we're going to get this guy spinning. I got to get this one a stir bar. So give me a second here. I got to get this one a stir bar. Where's my stir bars? Come on, where'd I put it? Dadgummit. I thought I had it all ready. People are waiting. I got to find my other stir bar. Crap. This will work. Oh, it's too big. That one's too big. So is that one. Dadgummit, where'd I stick it? Well, we'll just use this one. That's the best I can do. Well, here's a real little one. I think this one will work. This one should work. All right, pop that in there and get this one spinning. All right, there we go. Okay, now there's acid in both of these, so when I add universal indicator to both, we should see a color change. And the color change, if you've been paying attention, you should know what color change it's going to change to, since we're going to find out how much acid is in each of these sodas. All right. I'll add 1 full squirt of my universal indicator to the Sprite. Here we go. Oh, that's a beautiful red color. And we'll add 1 full squirt of my universal indicator to the Sprite Zero. Notice it's green, it's neutral at the start. And when I add it to the Sprite Zero, of course, it turns red because there's an acid in both Sprite and Sprite Zero. Okay. Thank you there, man of God. All right, now I'm going to back it up so we can keep track here. All right, you all are going to have to help me. You're going to have to help me here because I am going to need to count how many drops of base I add to both of these. Remember, we're testing Sprite over here on this side and Sprite 0 over here on this side. I've not added any drops yet. And what we're going to do is we're going to keep adding drops of base until we go either to neutral or slightly basic. Okay? Neutral or slightly basic. So here we go. I'm adding the same base to both. So it's going to be the same bottle. And here we go. Here's the first drop. Drop number 1 on the left. Drop number 1 on the right. That's 1 apiece. Didn't look like a whole bunch happened. So I'm going to go ahead. I'm going to add 5 drops over here. 1, 2, 3, 4, 5. That's a total of 6. Looks like we got a slight change over there. Come on now. We went from pH 3 to maybe 4, and then I got to add 5 drops over here. 1, 2, 3, 4, 5. So I've added 5 drops to both at this point. Excuse me, 6 drops to both. Thank you, 6 drops to both. And if you notice, I'm already seeing a difference. I don't know if you are. I've added the same amount of drops of base to both, and this pH looks like it's a little higher than this one, which is just a clue. I'm not sure about this, but it's just a clue that perhaps the Sprite 0 has a little bit more acid in it. Okay, here we go. I did do 5 drops, but I had added 1 additional first there, Jesus is King. Okay, so I'm going to add 2 drops over here on this side. So this is going to be, what we're at, 6. Yep. 7, 8. And over here, we're going to add, we're at 6, 7, 8. That's where we're at, 8 drops. I'm going to add 2 more so we get to 10 apiece, all right? I'm going to just try to even this out just a little bit. That's too close. Okay, here we go. 9, 10. 9, 10. Man of God, we drink stuff that ranges in pH from, 2 to 9. So the pH doesn't really, it's not a measure of how safe something is to drink, okay? Okay, here we go. I've added what? 10 drops to each. So here we go. Drop number 11 over here. And drop number 11 over here. It's still acidic. I haven't neutralized the acid yet. All right, here we go. I'm going to do 12 and 13. 12, 13. Ooh, we're getting close. We're getting close. And over here, 12 and 13. And 13. So I'm at 13. Riley, are basic compounds generally more dangerous than acidic? Not necessarily. Generally speaking, like very acidic things and very basic things are equally caustic. They're both just nasty. Okay, let's go to 15 drops. That means I got to add 2 to each. So here's 1, 2. That gives me a total of 15 into the Sprite. That's almost looking green. And then 2 more drops over here to the Sprite 0 to give me 15. 1, 2. Still hasn't neutralized the acid in either yet. It does look like the pH is just a little bit higher in the Sprite than in the Sprite 0. But I don't know. I'm going to keep doing this titration. That's what we call this in chemistry, by the way, when you measure, use careful measurements to try to figure out how much acid is in something by adding a base. Now, Wyatt, I'm his daddy. Okay, so here we go. I'm going to go ahead and add 2 more drops over here to get us to a total of 17. So here we go. 1, 2. That gets us to 17. And, oh, no, not quite. And then 2 more drops over here. to get to 17. So 17 to each. This, to my eye, looks slightly greener than this. Okay. That's correct there, mister. Okay, so we're at 17. I'm going to do 3 to get us to 20. 1, 2, 3. Let's see what happens there. Ooh, that's maybe at pH 8. Come on now. No. I'm going to let that rest a little bit because the carbon dioxide that's in here, it slowly reacts. You can see it got to like maybe a pH 8, but there's still some slow reaction that's pulling it back down. It's not quite at that 7 yet. Not quite there. So I got to go 3 more drops over here. 1, 2, 3. That gets us to 20 in both. It's such a gorgeous color. Yep, you can use this to find concentration. Well, it's interesting right now, folks. I've added 20 drops, both to the Sprite and to the Sprite Zero. And to me, I don't know about you, but it looks like this is a little bit more green than this. I'm thinking that Sprite Zero might have more acid in it than Sprite. Thanks there, Wyatt. Thank you there, Team CR. Here we go. We're doing some neutralization is right, Jesus. Okay, here we go. I'm going to add one more. We're getting close. I'm going to add 1 drop at a time. So we're at 21. Now it's like the color. It's kind of neat that, you know, the neutralization point is the same color as the can of Sprite. Make it overflow. All right, let's add 21 over here. Let's see what goes on. 21. Yeah, that's still yellow, man. I think it's got more acid. All right, let's do 2 drops over here. 22, 23. I wonder if that green color is going to persist. Somewhere around there, Jazz. I'm saying maybe 23 drops. That's where that green color is persisting. Let's add 23 drops over here. 1, 2. So we're at 23 in both now. I agree, Wyatt. It may have flashed and gone back. And this one's still not there, yeah? This one's still not there. So we're at 23 both. So it does look like that Sprite Zero has more acid than Sprite. I'm going to keep going just for the heck of it. So let's add 2 more to get to 25. But it did look like this was neutralized at 23 for certain. So that's 25 drops, and we're at pH 8 now. And then we'll add 2 drops over here. So we're at 25 each. And man, that one's still not neutral. Come on, baby. Oh, maybe we got it. Maybe we got, oh, I still think that's got too much yellow in it, yeah? We're still not there. We are still not there. We're at 25 drops each. This one's clearly been neutralized. So I assume there are other things in the antacid that can be present in liquids that make it harder to go one way or the other on the pH scale, correct? Yes. Like in your blood. Your blood has something in it. We call it a buffer that resists changes in pH, and that basically keeps you alive. All right, let's go here. We got 25. So let's go 26, 27. They were $40 a piece there, that special. So these were these right here. I've just bought them online. They're $40 a piece, plus I got a little stir bar. And then over here, 2 more drops to get us to 27. So this one's clearly been neutralized, right? We're at like pH 8. And I just added the 27 drops over here. Thank you there, Matthew. I appreciate that. I don't think that's quite neutralized yet. I mean, there's still a bit of yellow. We've got a bit to go to get to that green shade. Matthew, what I've done is I took some Sprite, okay, and I added it to this flask. I took some Sprite Zero and I added it to this flask. Then I added an indicator that tells you whether it's an acid or a base, just based on the color. And then I started adding base to both of them. to see how many drops of base it took to neutralize the acid. This happened, if I remember correctly, at 23. And if I remember correctly, we have now added 27 drops, and the Sprite Zero still has not been neutralized. Oh, it's fine, Jesus. People drink acid all the time, man. I mean, there's acids in your body. For example, vitamin C, which is required to keep you healthy, is an acid. Its chemical name is ascorbic acid. Okay, here we go. It's actually citric acid. That's the acid that's in Sprite. So I'm going to add 3 more drops to get me to 30. 1, 2, 3. So that's 3 drops in the Sprite. Okay, here we go. And then 3 more drops over here in the Sprite Zero to get us to 30. So alkaline water is Eustace. Master, in my opinion, yes. As soon as it hits the stomach acid, it's completely neutralized, and it does absolutely nothing to the pH of your body. What's the chemical formula for citric acid? I'm glad you asked. I'm prepared tonight. Looks like I finally neutralized the Sprite at 30 drops. Looks like we hit 30, folks, unless you think I need to add more. So here's the chemical reaction that just happened. This is the formula for citric acid. These H3 at the beginning, they give you protons or H plus ions. That's what makes something acidic. This is the acid that I added, the base that I added, sodium acetate. It formed water, and this salt, which is called sodium citrate. So the citric acid was chemically transformed into sodium citrate by the base. And it took 30 drops. When I added 30 drops to the Sprite, it looks like it got the pH all the way to 9, and the 30 drops just neutralized the Sprite Zero. And so in my opinion, based on these experiments, I guess it's not just opinion, it's observation, because it took more drops of base to neutralize the Sprite Zero than the Sprite, we can conclude, based on this, that Sprite Zero has more acid in it than regular Sprite. I'm thinking about doing this for, one of my YouTube videos. I do a lot of shorts. I'm thinking of doing a YouTube short for this. Empirically, baby. That's right, not so chirpy. Can we bet on a new soda drink? Yeah, maybe, team. I don't have any with me, but y'all drop in the chat, another soda you'd like to see me try. Here's the issue, though, folks. Here's the issue. You'll notice I chose Sprite to do this experiment with. Why do you think I chose Sprite rather than Coca-Cola? Why would it be difficult to do this experiment with Coca-Cola? Or Pepsi? Why couldn't I do it? That's right. These are colorless. These are colorless. And the Coca-Cola, the brown color is going to obscure the colors that we need to see. So it'd be a little tough. That's right, Jazz. That is right. It's too dark. You got it. Okay. That was fun. That was a fun experiment. Thanks for hanging out and doing that. Let's do it big style, though. We're going to do this big style. Sort of, maybe we can catch the rainbow tornado here. Maybe we can catch the rainbow tornado tonight. Let's pop this on here. What in the world is that? That's a big version of this. Come on, baby. Let's catch us a rainbow tornado tonight. Hey there, home bro. Hope everything's going okay. Caramel, well, Mister, tell me how I can remove the caramel coloring. Tell me how I can do that so I can do this on my live. I'm very interested. I would love for you to tell me how to do that. Here we go. Let's get a little bit more water in there. Let's get this spinning, baby. Let's see what's going on. Come on, I want to get this tornado going. There we go. Just give me a second here to get things squared away. Always takes me a bit. All right. Get going. Do your thing. Do your thing. Mister, I missed it. Let's see. Thank you, mister. I appreciate that. Okay, here we go, baby. Does bleach change the pH? It does, but unfortunately, it also, you know, bleaches the colors so you can't see it. Oh yeah, Jesse, I can buy some paper indicator strips. That'd be a good idea. Here we go. Let's add a little bit of base to this. Beautiful color switch, huh? Yeah, let's turn this light off. See if we get this light looking good. Get these lights turned off in here. Well, that looks creepy. Got a little creepiness going on back here. Yeah? What the heck? There we go. It's like a dark room or something. I don't know. Nice. Looks like magic colors. Here we go. Let's add another drop of base there. Come on, baby. Give me some beautiful. Hello there, baseball. Good to see you, man. And we are neutral for sure. Let's add 2 more drops of base. Get this going nice and violet. All right, now we're going to go ahead and add some acid. Where's my acid? Right there. Let's add a couple drops here. All right, adding acid now, so the pH is dropping. Thank you there, mister. I appreciate that. It's kind of pretty. I'm having a little trouble with my lighting tonight. Thank you there, Team CR. Actually, I think I want to add a little bit more color to this. I think we would benefit from a bit more color. I don't think there's quite enough universal indicator in there. Let's get a bit more color, folks. Deepen the color, make it look a little more vibrant. You know, there's a little art to this too, I suppose. I'm trying there, Jesus. We're trying to get to the rainbow. Yeah, make that a little darker. That's what I like to see. We are definitely in the acid pH region. Let's add a drop of base. I'm going to do 2 drops so you can get the rainbow going on. Boom, boom. Give another one. Let's get the flash. Come on, baby. Give it to me. I think we got it. We got a flash of the rainbow, baby. We can slow it down. We slow that speed down, and we get it a little better. Add a couple drops of acid here. Lower the pH. It does look tasty, but I'm telling you what, it's not going to be recommended. What's going on, Minecraft? All right. Let's add a little drop of, a couple drops of base here. Did you know green, when it's first found, was dangerous? Oh, that would be cool, mister, to use a fluorescent indicator. Here we go. Let's add 2 drops of base. See what we get. Thank you there, Team CR. Yeah, we can test what's in toothpaste. Toothpaste tend to be basic because they want to neutralize the acid that's on your teeth because, you know, teeth, you know, they don't like dissolve immediately, but, you know, if you expose your teeth to enough acid over time, it can eat the enamel away. The pH tornado, baby! Come on now. I'll do that if need be, baseball, but right now people seem to be behaving pretty well. Thank you there, Darius. All right. I am now going to turn this off. And we're going to pop some base in here and watch what happens. This is kind of fun to do sometimes. Let's just watch that slowly permeate the fluid and see what we get. And since it's, it takes a little, I think we already got a little bit of action going on. That's pretty cool. I'm putting on another flask on over here. We'll get that little guy going, okay? Look at that, folks. We got a little, I don't know what the heck is going on in there, but it looks pretty to me. Thanks there, Team CR. Hey, I don't know if you noticed. I mean, if you check it out, I'm getting close to 500,000 subscribers, folks. So thanks to those of you who have subscribed. I appreciate that a lot. We're like at, I don't know, it's like 495 or something like that, 495K. Last I checked, so we're getting close. So, if you have folks that you know that enjoy science experiments, send them my channel, baby. Help me get to 500,000 subscribers. Thank you there, mister. I appreciate that. All right, let's do that. Let's see what happens over here. All right, we're going to add some over here, just for the heck of it. Let's add a couple drops of base over here. Team CR, not like they used to be, buddy. Not like they were back in the day. And even then, I never was a big dude. Thank you there, Jordan. I appreciate the sub. Thank you very much. Yeah, making liquid oxygen is a little tough there, Ollie. I don't have the equipment right now to be able to make it. I have to try to figure out how to get that where I'm at right now. That's that one. But yeah, I got a lot of videos on liquid oxygen. Let's add a couple drops of acid over here. It's fun to play with, man. Liquid oxygen is definitely fun to play with. Hey, Jazz, thank you. Come on now. Come on now, Jazz. I appreciate that. Jazz just sent me $1.99. That's very, very nice of you. Appreciate that. Let's add a few more drops here. I'm running out. I'm running a little low on my acid here. I do have a microscope. Thank you, Queen of NASA. Thanks for entering the, thanks for the astronomer entering the chemistry chat. Jazz, you're too kind, man. Really. NASA has joined the chat. Thanks, you're special. I'm not sure that's a compliment. I mean, people tend not to like calling chemists. They like folks blowing stuff up all the time. Would I be able to see what's inside an enzyme? So, Jesus, an enzyme is a very large molecule. It's a protein molecule. So seeing inside an enzyme, I'm sure there's some equipment that can do that, but certainly not any microscope that I have. You're currently in your chemistry unit of physical science honors. Nice, Queen of NASA. Come on now. We got some of the chem majors and the science majors that have entered the chat. Thank you there, Sarah. Appreciate that. We're just hanging out here on a Friday night, doing some experiments, some chemistry experiments. It just looked beautiful. That's all we're doing. Nothing more, nothing less. Team, I wouldn't know. I do, Jazz. It's pretty fun, as long as it's done safely. Yeah, we just had a Halloween show that we did. We do like the self-lighting jack-o'-lantern, if you've ever seen that video. I did it with watermelons once. You check out my channel. You can see where I did the self-lighting jack-o'-lantern. I used a watermelon instead. Come on, Queen. I hope it happens. Keep dreaming. Keep on dreaming. And it's okay if your dreams change, too. Here we go. Let's add a few drops of base here. 1, 2, 3. That's kind of neat. It's like got a little stoplight action going on. You're welcome, Queen. All right, let's see this. This kind of is stopped, so I'm going to add a bunch of base here. Looks like a bunch of rain clouds dropping, doesn't it? Woo. Night and get some sleep. Go to bed. Ah, it's your generation, man. Your generation stays up late, man. I never got into that. I couldn't do it. Latest I liked to stay up when I was young was like 2 a.m. You're graduating high school third year with your degree, associate's degree, and go to college majoring in a science field, minoring in music. Cool, man. That's cool. I don't have any Team CR. I apologize. I got you, Queen. This is what this one looks like. Looks like the nighttime. Hey, Macon, how you doing? Good to see you. All right, let's add some acid over here. See if it disturbs. Clarinet, very nice. Look at that. That's like daybreak breaking through the night. Yeah, so what's going on here? Hey, Hamza. Thank you. Thanks for the kind words. I appreciate that. We got a chemist that's entered the chat here. Hamza. Got through Gen Chem 2. Probably taking organic right now. Tell you what, man, the students I teach, they are wicked smart. They are so smart. The stuff that we ask them to do and they do it, they're awesome. So someone's playing, Queen's playing violin. Cool. Okay, so the question is, what's going on? Let's tell you what's going on. So in both of these flasks, it is beautiful. I mean, it's really pretty. In both of these flasks, I have added universal indicator. Universal indicator is a mixture of chemicals that change color depending upon pH. pH tells you how acidic or basic something is. So in this flask, we see a variety of pHs. I see some red right next to violet, and that's pretty remarkable. That's correct there, that. Really remarkable, because the pH scale actually goes by powers of 10. So, for example, a pH of 3 is 10 times more acidic than a pH of 4. And a pH of 4 is 10 times more acidic than a pH of 5. So what you're seeing here is a pH of 3 right next to a pH of 10. So the difference in acidity between those two regions, basically acid concentration, is, here we go, 10, 100, 1,000, 10,000, what's the next? 100,000, a million, 10 million. So there's regions here that are really close together, that difference in acid concentration by 10 million times, which is really kind of cool. Yeah, it could be a pH of 9, and if it is indeed a pH of 9 and a pH of 3, then the difference is like a million. So maybe I was exaggerating a little bit. Come on, mister. You've almost got, in my universal indicator, it's slight. There's different recipes. Thank you there, K2. In my recipe, it is, I'm trying to remember, bromothymol blue, phenolphthalein, thymol blue, and, what's the other one? Curses, I can't remember. Bromothymol blue, phenolphthalein, methyl red, and thymol blue. That's what's in my mixture, my reaction mixture. Yep. Well, it's possible because they're just not being mixed. You know, if I turn this on and they mix, you know, there can be regions. There can be regions that just are different pH values. Nice there, Queen. No, mister, there's just different recipes for it. You may have given me a correct recipe. Please mix, says Grayson. You got it. Here we go. Let's mix it up. If the acid and base are in equal amounts, it's going to turn green. They will neutralize each other. And look at that. They must have been present in roughly equal amounts. All right, I'm running out of steam here, folks. What I do near the end of the live is I just flip the camera around and you get to look at my ugly mug if that's something that you want to do. I'll say hello, we'll talk for a little bit, and then I'm going to call it quits for the night. I got to turn my brain off so I can get some sleep. So, you know, if you don't want to see a 50-something-year-old man in his basement, then now's the time to definitely leave the chat. So we'll be flipping this around really soon. Here we go. Flip this baby around, talk to people, let you see my mug. These are my reading glasses here. So you might be able to see. Yeah, you see it down in there. My readers. I can't see what's going on. I mean, I could wear these. I just don't look as cool, of course, when I wear these. We'll just pop them on. I don't care. I don't care. Here we go. Yeah, it looks a little like that trick. Where I'm at, it is now 7 p.m. Hello, K2 from Germany. That's my ethnicity. I'm like I don't know, like a 10th generation German over here in the United States. 419 in Las Vegas. Nice. Nice. How you like the shirt, man? Pretty cool, huh? You're too kind, Queen of NASA. I'm definitely over 30. I'm good, Ollie. How are you doing? Yeah, that's right, mister. I am a chemistry teacher. Yep. Indeed I am. 719 in Ohio. Nice. I'll leave those on. Leave those lights on. I look a little better with the lights on. I mean, I look bad enough. Thank you there, Grub. That's like a NASA shirt. A little bit of oh, nice. Mr. Majored in Chemical Engineering. Thank you there, Jazz. I appreciate that. Thank you there, Ice Cream. I appreciate that. Jay, thanks for the sub, man. You're helping me get to 500,000, baby. Any mechanical engineering degrees out there? I don't have any. Why, Jazz? Why did I start teaching science? Hello there, Nagi. I don't know Walter White. So what encouraged me to go into chemistry? Why did I show them biceps? Come on, man. Look at those biceps. I'm an old dude. So, yeah, I mean, I was good at science. I was good at math. I actually went to college to wrestle. You might be able to tell that from this goofy looking ear over here. Or this one. I don't remember which one it is. I think it's this one. And, I was pretty good at math. I was pretty good at science. And then, I had to take a lot of math and science courses, and I fell in love with it. I had a chemistry teacher who did experiments in class, and I thought it was really interesting. Hey, thanks there, Jeremias. Appreciate that. I should go soon because I spilled a little bit. You can see I spilled a little bit of the universal indicator on my hand. I should probably wash that off. Probably be a good idea. Have a good day, Jeremias. I appreciate the sub. Big time. But hey, thanks for hanging out and checking out some of the beauty of science with me this evening. It was pretty fun, man. We saw some pretty cool experiments. That's cool, mister. Thank you there, Grub. Appreciate it. Yeah, we checked out some cool experiments. And thing is, I mean, the beauty of science is all over the place. I mean, I don't even need to do anything. You just sit here and watch this vortex. To me, it's beautiful. I mean, there's just like goofiness there that you can toy around with. And just paying attention to the beautiful blue sky or the clouds, the sunsets, the sunrises, just gorgeous. So you all have a great evening. Thanks for hanging out and doing some science experiments with me. Appreciate it. And I will, I'll be seeing you. I usually do my lives Friday evenings when my wife goes to yoga. And yep. And we'll talk to you later. Okay, folks?